okay. Yes. Can you hear me now? That's weird. I've way too many profiles in OBS and all of them are bonkers. Absolute bonkers. Anyway, now that that's sorted, hello Fire Goose. Let's see what we can do. Oh, I think my chat window has stopped working. Let's see if I can fix that. The pop-out chat. This is all going surprisingly badly. Hey, Yuri Alexandrovich. Yuri Alexandrovich. How is that? Is that close? Is that pretty close? I like to think it's reasonably close. There. Now the chat is working, and I'm going to start seeing about designing something for the Atari ST. Now, I've got a lot of stuff here, but what I wanted to do is design a daughter board for the diagnostic cartridge we made, and I should really have one to hand so I can eyeball that to see how it might all work. But I'm going to base the design off the old one, so let's delete some of these copied folders. Again, this is in Eagle version 8, free for most people. Let's delete the old Gerbers as well, because the last thing you want is any of the old stuff going out by mistake. So it's called Atari ST Diagnostic. That was the name of the actual main board, but I'm going to call it LED Daughter Board. LED Daughter Board should do, and then I'm going to change that to LED Daughter Board as well. So you know that if you've used my diagnostic board, that it kind of works reasonably well. And there we go. There's the whole circuit, but I'm gonna make it not quite full screen because I haven't set up my video profile yet to sort of handle that in any nice way. So we'll do that. And the idea of this is, of course, you plug it into your Atari ST and it loads the ROMs, and those ROMs contain a diagnostic, and those ROMs occupy 2 banks, and you can see all the different banks here. So what would be nice, of course, though, is to see when you are trying to write to your Atari ST cartridge port whether or not you're actually getting through. What is that noise? Crikey, there's my Alienware is going nuts in the corner. What the heck is it doing? I don't know if you've got Alienware laptops, but they just occasionally just ramp up the fans to like ludicrous speed. But anyway, back to where we were. So these are the address lines. You can see them here, address 1 to 15. So hang on, 1 to 15 is an interesting number, isn't it, as well? Because it's not as many address lines as you'd normally hope for, would you? But you can see here, A0 to A14, so it's not the 8 to 16-bit. And then you've got your byte of data out coming here. And then you've got your output enable, and you've got your chip enables on those. So really, you can see for most cases when there's data traveling along the bus, you'll be able to get the address LEDs going nuts, and you'll be able to get the data lines going nuts. So the idea is to make an add-on for the cartridge that you can plug straight in. And I'll just grab the cartridge real quick so you can see what it looks like if you haven't got one. Okay, so there's the cartridge. So you're probably familiar with these. If you go on backoffisshow.com, you'll be able to see one of these. And they plug into the ST that way. So the actual EPROMs, or yeah, proms, they're not electric. They go in underneath. So if we want to mount something, we'd probably want the LEDs to actually be on the top. So that's kind of the opposite way. So it's almost like you have to fit a socket on the opposite side that you'd expect. So that's not a problem. So what we need to do, though, of course, when we do that is design the pins appropriately. So maybe we might even have 2 versions. Let's have a little think. I guess you'd have to decide how you want to do it. For me, I think I would put a socket on the top, possibly on both, and then have a daughter board that just actually maybe even sits on top. There's a lot we can do. We can add some buffers in there, but sometimes we go a bit too crazy and we'll do too many things and then we'll ruin it. So let's not do that. So what I'm going to do first is, looking at this, we're going to decide the two empty slots we have here are on ROM 3 low and ROM 3 high. So that's these two on the top. So we've got those two. So let's just remove these ones. We'll assume these are populated, as they will be if you're running a ROM in them. So you'll have two slots. And if I flip this over, interestingly enough, you'll see this is kind of cool. This is why basing it on your existing design is cool. So that's the outline. What we can do is, if we remove, I'm going to pull up the rat's nest, and if we actually remove the edge connector, we have a really good basis to make a board that will just slide on over the other one. So we can get rid of those. So you can see we've got the tracks there. You've got a couple of capacitors we don't need anymore, and I'm not sure which ones. To be honest with you probably don't need any of these, but I'll leave the footprint for them anyway. So these capacitors just help with noise. And this bit on the left here, this is your entire Atari ST cartridge port, cartridge slot, which we don't need anymore. So we're probably going to blitz that while we're at it as well. Just like that. And then I'm going to move this one up. And I'm just going to post this on GitHub, so if anybody wants to make this. I don't know if I'm going to make the board myself right now, because I've got a lot on my plate, really. But someone will. Okay, so I'm pretty happy with that. So I'm going to make this full screen as well. And we're just going to have a quick look at these components to see where they are, because they are on. So you've got to be very careful. So you see when they're blue, they're on that side of the... Hey Bazza. It's not my Atari obsession. It's just, you know, if we're doing stuff, we're doing it properly, aren't we? And it means we're going to continue to do stuff. So that, there we go. So I'm just looking at the board here. As it stands, right, you could literally mount this card straight on top. In fact, if we just trim down, how's it going, Bazza, anyway? What are you up to these days? If we actually pull it here, you'll have a 1-for-1 card that will actually sit exactly on top. Oh, look at that bloody mouse cursor. Grey on grey. Hard to find. So I'm going to put that there. So I can remove the corners. I think you can delete corners on this, but let's see. That's kind of not what I wanted. There's a way to remove corners. Is that it? Optimize? No. Anyway, we'll fix that momentarily. So the idea is, if you want to, you can make a board like this and base it anything else you want on there. So a lot of people were talking about buffering, because we were trying to run an Arduino on it, and I have to admit I didn't really persevere with it too much, but I did seem to get the Atari ST communicating with the Arduino, which gives you a lot of potential if you think about it for projects, because that way you can just use the Arduino to do all your GPIO and send the data to the Atari. It's kind of neat. Oh, you're decorating. Double glazing. You posh people and your double glazed windows. So I'm going to move these over here. Just get them out of the way for now. In fact, I'm going to move them off the picture. Right. But when I finish this, I'm going to put the back office logo, because I've told everybody so far now on everything that goes on the Atari ST to have the back office logo up. Because if you plug these in upside down, you blow up the EEPROMs, and we don't want that. So we've got this going now. Let's decide how are we going to handle this. So we could have a bunch of blinking LEDs. I think blinking LEDs are pretty yeah, a decade of single glazing. So we could have an LED per channel, So you can imagine we've got 15, 16, 17, 18, 19, 20, 21, 20, 23 odd LEDs, which I think would look pretty sweet, actually, to be honest with you. Or you could try to put a 7-segment screen, and we could put a controller for a 7-segment display. The downside is, now you've seen them in motherboards where they have 2 digits of 7-segment. When this is running, it's going to be going brrr, you're like mega fast. So in general operation, and then when it slows down, we're just going to be manually tweaking address lines and data lines potentially. We'll be able to probably hold them a bit longer. So I don't think the 7-segment's going to work. So we're just going to figure out how we're going to put in some LEDs. And I'm wondering if we've got an LED driver. I'm not sure. I've not really looked into it. But if you've got a lot of if you need a lot of transistors, hey ZX Renew, tell me, Mr. Renew, if you've got the need for a bunch of transistors, is there a transistor array we can use? What can we use? Otherwise, we're going to have to paste down a lot of transistors, and I don't fancy the soldering involved in that. I mean, it's something... Oh, hang on. Quad. Quad transistor. Quad transistor. That's a lot of transistors. Is there any more? Let's look through the... So these are all single transistor packages. I like the idea of a quad transistor, though. That sounds cool, doesn't it? I'm just looking at the pictures as I'm flicking through. Just looking. Whoa, 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 whoa there. Whoa there. A transistor array. What do we want? Through hole or surface mount? I think surface mount because... Oh, look at that. That is some sexy beast there, isn't it? Jeez. Jeez Louise. Right, so how many have we got there? 4, 5, 6, 7. So I think we're going to need a few of these. Boom. Boom. Shake, shake, shake the room. And let's see how we're going to drive our LEDs. I'm going to just show, I'm sure... where are we? Where's our library? Let's get an LED going on here. Ooh, through hole. Exactly, hole in one. So we need some LEDs. Not those kind. Oh, look, you get ring LEDs. Look at all this. Did you see that? We just had a circle there. That would be cool. Right. Anyway, regular LEDs. What have we got? What? There's such a thing as LED arrays. Look at that. 4. Oh no, they're just all in parallel. It's just like a super bright thing. Whoa! What? This is crazy. Yeah, I never thought about that. We could use bar graphs, right? How many would we need then? Let's work this out. I'm gonna count them up properly now. So we have 15, 16, 17, 18, 19, 20, 21, 22, 23. So what's a good block of that then? 9, 18, 19, 20, 21, 22, 23. So what, 2 9s and a 6? Or 12, 6, 7, 18, 19, 20, 21, 22, 23, 24. You know what I mean? What combination of LEDs do you want to do? Or do you just want to solder them all down by hand like a soldering person? So ZX Renew, we are doing a data line monitoring daughter board here for fun. But we could have some extra lines, couldn't we, for the UDS and the thing? So, yeah. So we said 15, 16, 17, 18, 19, 20, 21, 22, 23. 24, 25, 26 we could do with. 26. What is some good divider? 26 over 4. No, it doesn't go. 26 over 4. Yeah. 3 9s? Is there a 9? There's a 10. No, there's a 9. Look, let's just chuck these in and start putting some stuff down before we get too confused anyway. So I'm just going to put those there. And I'm going to put another one there. We'll work it out as we go along. And then we need a bunch of resistors, and It's the first time that we're using arrays, isn't it? I've never used the resistor array components. I've never bothered. For I don't know. Let's just chuck something in. See how will they line up? Of course they bloody won't line up. Look at that. Nothing lines up. Tell me about the illuminated solid. I think is that when it's running. Are you worried that when it's running we'll see it on? But don't you think the lines will just flicker? I kind of feel I'd want to see them flickering. So if you've got an Atari ST that's working, I think I'd want to see all those data lines, the bus lines flashing all the time. I see what you mean though, some sample and hold. Yeah, but that's the question. Do we want to actually read the exact values off the lines, or do we just want to see that they're working? You know, so a lot of people using the cartridges, when they use the test cartridge, right, and the ST is like more dead than can actually boot the program, I kind of feel the next stage is to understand if the bus is doing anything or if the bus is just jammed up. So I don't know. But yeah, if you tell me, I don't know about buffer and hold. Could we use a VU meter IC? I mean, that's a potential. Let me just look at that before we go crazy pasting all of these things down. Let's just see if there's a useful VU meter IC out there. VU meter IC. But probably VU meter, of course. They're going to be analog. Yeah, and if we want to make a sampler, at that point, if we're going to make it sample, I'm almost wondering if we'll just have a microcontroller sample it when it wants. Whether or not the microcontroller can be totally invisible to the bus would be the challenge, potentially. What's this guy doing? What's this thing here? Oh, these are the outputs here, so that's just using that based on those inputs. Yeah, I'm going to have to change my search criteria. Yeah, I don't know, but is a microcontroller really going to be too slow? Prepared to do what though? To read all the lines? I mean, yeah, it's whether or not it can read the lines in time before they. Yeah, but then if we're going to CPLD and actually just going balls out on this, it's kind of a bit more than most people will have at home to program, isn't it? I kind of think the idea of this was just to help people along, see if their Atari ST is dead. If we're going to go with CPLD, there's a lot more interesting projects I think we can do than just flashing some LEDs. We could just write a whole interface to the ST to kind of do what we want. So it's a tricky one. I don't know. Otherwise, we'll not get anything done, will we? let's just do this one for the hobbyists, and then work out what else we might want to do. So I'm going to copy this component here, I guess, because I don't really like what I'm going to have to do here. But I'm being lazy, and we just want to get something laid out, don't we? This is not about optimizing the layout. This is literally a throwaway design, pretty much. So let's see what would happen if we were just going to wire it up in a really dirty way, which is what I'm doing now. What's going on here? This is being a bit weird, actually. How does it actually handle these? Is it handling them as separate entities? Look, you see how, and they're not even connecting. Why isn't it bloody connecting? Do you see that? Hang on a minute. I don't like how this thing's packaged. Do you see there? It's literally not joining because they've done something to the spacing of the footprint. That is the lamest thing I've ever seen. You know what? Screw that. Screw all these array components. If you're at home making this, you're just going to want low-level stuff that you can just buy anywhere. let's just get regular resistors, regular transistors, and chuck it on. And if you don't like it, change it in the design on GitHub. So, through hole as well, because you always whinge when I do surface mount. Hey, Costada, how's it going? Costado, are you looking forward to the weekend? I bet you are. Yeah, it's been ages. I was kind of gone off the whole thing, to be honest with you. The whole YouTube streaming thing. And then, you know, you get in and out of it, don't you? It's like having a little holiday. How big is this guy? 5 mils. Yeah, I mean, any of these will probably do, to be honest with you. Let's just chuck that in. You can put it there. Let's do that. Hey, how's it going? We're all, it's like the whole gang is here now. The whole gang is turning up. Everybody turns up for something to do with the LEDs. More LED than Big Clive. Oop, come on. And you missed me slurping some tea and having some digestive biscuits earlier. Oh, that was gross. That was the last cold mouthful of tea. Come on, don't crash now. Please don't crash now. Please, please don't crash now, Eagle. Don't crash now. Oh, thank gosh for that. Right, before I do anything, I'm just going to hit save. Right, now let's try again. LED. I'm guessing it took its time because there's a lot of LEDs in the world, but I just want a standard package for you. And I can hear a grinding sound outside, and that's the soothing sound of my lawnmower hitting a divot. Poor little guy. Right, I think we're looking. It's starting to look like a thing here. We're going to pop that there. Boom. LED, boom. Resistor, boom. All of the boom. What? Has anyone seen that Joker movie? That looks kind of cool too. Come on, you cotton picking thing. Why won't it do this? Why won't it? Is it literally? I thought now that they've changed Eagle that literally if you hit, it's okay. If you hit a certain key, it's jumping back to the select. I think it's if you're hitting escape twice. So we'll avoid hitting escape twice. Look at that. Look at that. That's what we want. Yeah, I think it's Costado. I think there's a T threshold. Like the T has to be suitably like if there's a warm, and then there's a cold, and there's like a tepid, and then there's cold. So if it's cold, it's okay. But if it's in the tepid region, it's undrinkable, and you can't forgive it. That's the problem. It's a bit like food, though, isn't it? To be fair, not Luke cold. Yeah, exactly. So that's your first set of LEDs, and this is going to be the most amazing thing to lay out. You'll see once we've drawn all of these bastard things. Oh, you got to see what it will be doing in the schematic editor. It will be going nuts right now. It will be absolutely going nuts. Oh, that escape thing. There's a behaviour in this version of Eagle, I can tell you. It's not a good behaviour either. It's bad behaviour. It's on GBH. Right. Ooh, so how many you got there? We got 8. I'm just going to copy this whole lot because I think that's fine. I think that'll be enough. Look at that. Boom. Right, now just to show you the mess. It's just dumped them there in no particular order. And look at that. Look, I've got to try to even fit those. Now, I have got the benefit, of course, of extra space because we don't need 2 slots to read that, and I can kill one of those ICs. I'm only just keeping it there because I kind of think it would be nice as an anchor point. But that's fine. That's fine. This is going to be awful. Right. I didn't tell you it was going to be a proper design. It's not a proper design where we sit for like a day just to contemplate how we're going to do it and looking up data sheets. This is just being absolutely awful with it. And rightly said earlier in the stream, if you were going to do this properly, I would definitely be investing how to put some buffering for microcontrollers, because I want to get microcontrollers talking to my ST. I want to use them for I/O. I want to use standard micros. So I should really be investing some time in that. But it's Tuesday night, right? And I'm busy. You're busy. We're all busy. And we just want to do a thing. This is virtually the equivalent of playing video games for me right now. And I could be. I've got one of those Oculus Rift S's came today, earlier this evening. And I plugged it in. If you remember, of course, we had the earlier Oculus Rifts. We were playing games with that. And this thing's good because you don't need any of the, the pods with the sensors in them. You can it uses a camera inside, which is pretty cool, and it just uses that. So A15, boom. Look, I thought when I cut and paste those that we had like way more than enough, but we don't. We don't even have enough yet. So we're going to cut this here. We're going to move it down to so we might add some for the chip selects and stuff for fun. But let's just get on the address lines for now, the data lines. So you can see I've left the base. Oh, crap. Okay, I'm gonna do. All right, first one to tell me what mistake I've done wins a prize. And I'm not the prize, and it's going to be an amazing prize. It'll be a virtual prize, of course, because I'm not going to send you anything. But I have made a horrible mistake. That's going to cost me a lot of clicks. If I fix the mistake now, you'll get it. You'll know what I've done. So I'm kind of not going to fix the mistake. I'm just going to do some looking around and just practicing the layout while you tell me what hop. No. It's transistor related though. ZX Renew. It's definitely transistor related. Also, look at the size of these friggin' resistors. Are these 1/4 watt resistors? That's a mistake, but not the worst. Hang on. These components just look massive because why do they look so big? I guess they just look big because I'm used to surface mount stuff. Through hole. My gosh, guys, how can you use through hole? Look at it. It's ginormous. This is going to be a nightmare. This isn't going to be doable with traditional electronic components. Anyway, I'm going to keep battling on while you guess. I think you're pretty close, actually, ZX Renew. I think have a little bit of thought more, a tiny bit more thought, and you'll get the answer on what I've done wrong. You're nearly there. I'll just show you again. Have a look at any of these LED setups here. Okay, have a look here. Think of your transistor. You've got your base, your collector, and your emitter. And think about how transistors work generally and how you normally hook them up. Or look up any circuit that uses a transistor and then look at mine and go, yeah, you done blown that up, boy. So you're saying maybe use open collector logic or bus drivers with current enough to drive the LED. Maybe. I don't know much about those things. So that might be a good thing to try and do. I'm going to tell you. I'm going to reveal how I've screwed up here. Because effectively, if you hook up the base of the transistor straight to the bus logic, right? How many volts are you going to be trying to hit that base with? And how much current are you going to try to draw through that? So if you're going to hit that, you'll be putting 5 volts. How much do you need on a base of a transistor normally to activate it, right? You're going to be looking at is it 0.6 to 0.8 volt of a volt? So you're going to have a nice big resistor in here. So you can't hook up all the address lines directly. You'll actually need obviously another resistor in between all of these, which is not only doubling your resistor count, but just because I've drawn it wrong, and now I've got to go and add, delete all of those, and then put them all in. The things that I so painstakingly cut and paste to save time. In fact, it's probably easier at this point to actually just delete all of those. I think I will do that. Just delete those and just get it right, and then cut and paste the design. Otherwise, so if you're doing this at home, I think you should just do the same. Drawing them in one at a time is just going to introduce the opportunity to put in more mistakes, I think. And it's not too bad. I mean, it would have been a boo-boo to go and get that PCB made. And that would have been embarrassingly bad, wouldn't it, if you had that made without the resistors. So we're going to pop that in like that. Do you see it there? Yeah, I think we need through hole on ST projects, don't we? Absolutely, I agree. And we're going to pop that there like so. Boom. And that's going to be the address there. I'm going to leave it like that. So you can actually put values, by the way. We haven't signed any value, but I'm going to just put nominally at the minute like 1.5k maybe, or 1k. That would be all right. And then maybe 330 ohms for that guy. And I think the rest is okay. I'm kind of wondering if I should bring this wire up to match because it will be aesthetically pleasing, but not just yet. So let's have a look here. We've got this one actually laid out almost. This one, of course, is going to an address line at some point as well. But I just want to see if I can get a nice little compact layout here now. We're going for it, aren't we? So let's just do it properly. Now, are those resistors? I think those resistors we could probably find a better footprint because... What's my grid spacing even? Look at the grid spacing. So you could fit something like that. If we can get smaller resistors, I think you can get that all in quite neatly. So we'll try that. What resistor footprints do we have? Does it have the wattage? I kind of feel these are too high a wattage. So just type 204. So these are just all the various standard types, and there's your surface mount. Let's just go for the 204 then. I mean, that one looks like a resistor on its end, and I'm not really keen on putting resistors on the end. However, if you were looking inside your Atari ST, you'd find loads of resistors on its end. So I'm prepared to take a vote on that, guys. 204V for vertical or 204-5. You let me know while I play around a little bit. I'm going to just do a part swap. If I can find the icon, replace. There we go. Boom, boom. I think that should have done it. Yeah, it has. So yeah, I'm thinking these are actually okay. They're almost sometimes a bit of a nightmare to put in when the legs are like that. You probably would prefer them to be vertical, to be honest with you, but that's fine. LED. That looks all right. Something like that. Vertical. Castado's in there with the vertical, so that's 1-0 to vertical so far. 1-0 to vertical. Castado, you're a winner chicken dinner at the minute. I'm going to let anybody else, if they want to chime in while I still play around with these components. I've got a few bits of housekeeping to do here. I'm just going to make sure. I want to make sure the board is all the right way up when I'm done. So any more? I'm going to give a countdown. 20. 19, 18, 17, 16, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2. Vertical it is, Castado! Yes, and anybody who doesn't like the verticalness of it will have to blame you, Castado, and I'm going to direct them to you. Boom, boom. Let's have a look at that. Oh, yeah, and it didn't even give us that much benefit. That's the best bit about it. It doesn't give you that much benefit, but it makes it way more awkward to install. So that's what we want. It doesn't matter for us. It's those poor kids in China who are going to be assembling these. Right, now how can we... I'm just going to check the LED because we might want to actually reduce the LED size because we're trying to fit 16 LEDs. And looking at my screen here, I don't think we've got 16 LEDs. Anyway, let's just cut and paste this thing again. Now, it would be awesome. I'm sure there must be a way in Eagle where you can cut and paste. Let's try and see what happens if you try to copy this part. No, you can't. You've got to do it in the schematic. That's a downside with this tool. Good thing they have tiny hands. That's true. The teeniest hands. Hands that do dishes can be as soft as your face, with mild green fairy liquid. Look at that. Look at that. That's looking confusing. The more confusinger, the better. Now, again, I'm doing all of this without bloody checking that LED dimensioning, but that's fine because it's easy to delete them. But let's just do some LED dimensioning, seeing as we've got them here. Move. They're like tiny elves. Do you have elves, Custado, where you live? I believe you live somewhat in the land of the elves. Okay, 3. It's looking tight, guys. I'm going to level with you. We might want to surface mount some of this. You might have to just put up with the old surfacey mounty. Look at that bloody thing. We've got so many LEDs to put in. Remember, this isn't even all of them. Right. Let's just move the whole bloody lot. Got another 3 down here. Let's get them a bit nearer the workplace, basically, so we can do something with them. Institutionalized blackface. I've been to loads of countries, I think even Cornwall, where they have blackface, and I don't know really. I find I'm confused over tradition versus what's offensive, what's everything on it all at the minute. Have we got more LEDs hiding? Yes, we bloody have. Look, there's another 3 LEDs here. I wouldn't have thought it was possible, but there is a point where you have too many LEDs to worry about, and that's why we don't make things with hundreds of LEDs. Look at this. I reckon when you're running it as well, the low address lines will be really illuminated all the time, and the high ones will be flicking around. Right. This is where you might need a driver. So I think we're automatically going to have to go to surface mount. I don't think this is feasible. This is not feasible, guys. What's your opinion on this? Do we make this fit? I mean, I could get rid of one of these IC footprints and we try to make it fit, but we've got another at least 8 to come as well. So 1, 2, 3, 4, 5, 6. Oh, we can't even fit a byte. You can't even fit a byte in. Okay, here's another idea then. Why don't we remove one of those and then fit them all horizontally? Because if you imagine this is plugged into your ST and you're looking at it, you'll want to look at it like this way anyway. So that would be like a row here. So 1, 2, 3, 4, 5, 6, 7. Let's just I'm just space. I don't know why I just come up with making up a word. I'm just space shaping it, guys. It's going to be this space shape. Oh yeah, it's not quite the full 2 bytes though, was it? Oh, it seems to be. Yes, it is. Am I losing my mind? I thought it was 1 to 15, not 0 to 15. How does that work? Or was I was just cutting and pasting randomly. That's why. So it's something like that. Hey Rob, we're making a oh, they're black from the soot of the chimneys. Okay. Rob, we're making a thing for the Atari ST. If you remember that we have our diagnostic cartridge. This is a daughter board for the diagnostic cartridge to give you bus diagnostics, so you can actually just see the buses working. However, that being said, we made some design decisions on this that might not be optimal. Although I do think this would work. I think this would look all right. When I say it might not fit, the LEDs would fit, but I'm not sure all the transistors and stuff will fit. They definitely won't. But I do like this idea of when you plug it into the ST. I'm just going to hold this up so I make sure I've got this right. Yeah, so you plug it into the ST. You'll see here all the... so that my hand here is the ST, ka-chunk. And then here you're seeing all of the LEDs, like old school. Hey, Atari staff room. Nightlight. Yeah, it would be like a bloody nightlight, wouldn't it? It's got so many LEDs. Right, I think we're going to go for surface mount. And Rob loves surface mount, so he doesn't mind. And the rest of you that do mind, well, you're going to be outvoted by Rob, because Rob, he's the expert. Aren't you, Rob? Yes, I am. I am the expert of all things. Right, let's do a part swap now. Resistor. Surface, please. So I'm going to keep it cheap again by not using arrays. We're just going to keep chucking it in. I don't know what size you like. With my DigiKey ruler, that's got them written down. Okay, so if you have a DigiKey ruler, you will have on it footprints for all of the different sizes of stuff. So I'm going to dig out what we're going to use there. I think you guys can handle an 0805. That is my view. An 0805. Of course, I got to search for them. There's not going to be any sensible way of putting them in there. Where were we? What? Why are we? Yes. 0805. Where are you? Where's all my surface mount resistors gone? There. 0805, that's what we want. Okay, so we're going to change that one, boom, that one, boom. And we're going to go for, again, surface mount LED. 0805, if we can find it. Let's get down there. And something I'm going to look at, we're going to have a look at that Oculus Rift S later, perhaps. I want to see what it's doing for illumination, because it's got cameras, but I don't know if it works in the dark. So I kind of feel that would be curious to see how it sees at night. Come on. Oh, Rob, you don't like their smaller size? You don't like the... Where are we? The 0402s or the 0201s. In fact, to be honest with you, I think I've tried to use 0201s and they're really hard to work with. But you do get a lot. A little strip of ribbon will give you just hundreds. Come on now. Work with me. It's gone to sleep again, guys. There's too many LEDs in the system. There we go. LED. There we go. Osram. I can't tell what size that one is, so we're going to go to the 0805 ones. Definitely 0805, and then the final one is just the transistor, which is going to be... What size is it going to be, Rob? SOT 23? NPN. Oh, Oh, there's a SOT 89. I think they're a bit big. So we're going to go SOT 23. Bang. So let's have a look at that. See how that might fit. It's looking a bit tidier now, isn't it? Although it looks more boring, doesn't it? It doesn't look as fun. And admittedly, I'm not even sure. You're not saving that much on the transistor and resistor side, but you're gonna save on the LED density. So to make this work, you really want to be able to fit these in a line. So Rob, tell us, you're doing the Amiga board, and I'm sure it's very popular. Are you not tempted? Were you not tempted to do some surface mount in it? You know, break the tradition, the Amiga tradition, and go surface mount. Because you'd have probably made certain things easier for yourself doing that. Let's copy that. So we're going to need loads of these. Just trying to figure out the keyboard shortcuts now on Eagle, if there's a way, like when you've done the last operation, you see when I click it goes back to select mode, but it shows the ones highlighted. There's something weird because it's doing that, going back to select mode. I think that's new and annoying behaviours. So is that you forever now, just going to keep making variants of the same Amiga PCB, or do you think that eventually there'll be enough people have fixed them all, or are there just infinite amount of Varta batteries killing Amigas right now? Okay, so that's the first batch to lay out. But I think like last time, what I'll do is just focus on the LEDs really, just to see what that's going to look like. And it's going to look a little bit of Monica in my life. Oh, by the way, I was recently on an aeroplane and I watched a bunch of movies, and I have to say, if you haven't seen it, go and watch Destroyer, starring Charlize Theron, because it's one of those movies that I don't think will have done well in the box office, but it's definitely a really good movie. So you might not have heard it because it won't be that, you know, popular. But it's good. It's real good. Oh, look at that! I think that's if that. It says LED 13, but I've not been putting them down in order. We'll have to count up to see actually how many we fit in this way. I reckon you can get that many in a row like that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, I think you should put a Varta battery on there, Rob. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So we can go with 2 rows. I think that's what we're going to end up with, is just 3 rows. So let's just put them in the right order now then. So that's 1, 2, 3, 4, 5, 6, 7. Where's 8? No 8. You need an 8. 11. Oh, maybe. Where's my bloody LED 8? I think there's quite a few people had the old Varta destruction on the Amigas. I bet you wish it just didn't have a bloody battery on it. I'm not sure what value you got out of having a real-time clock, really. 8, 9, I remember like there was loads of real-time clock upgrades for things in the olden days, but it's like I don't know who for people using your BBC Micro in an office environment or something. Where's my LED 10? There we go, 10. 9. 10, 11, 12, 13. So we need an 11. 11. It's a problem with all these surface mount ones. They all bloody look the same now. 11, 12, 13. 14. Oh, we can snag 2 with one go here. $14, $15. And then there's some spares. We've got some spares, that's fine. Oh, bloody eagle. Right. $16, $15. So one more hide-in, and then we're done with those. We are building, Delvin, we're building a bus monitoring solution in the least optimal way. So I'm going to say we're building a soldering practice board. That's about as accurate, I think, as I can be, because you're going to be doing so much surface mount soldering. Or it's a PCB software laying out practice board, because that's equally as valid. I'm even like getting confusing myself as how we got to wire these up. So we've got odds and evens basically going on. And the idea is when you're using the diagnostic cartridge, if your Atari ST seems to be a bit dead, then this is a further level basically of diagnostics. But assuming you don't have an oscilloscope, making this board, which would probably cost you a tenner in bits, might be handier. Look at all these friggin' parts down here. Why does it put them so far away? I'm going to see if I can shift them up a bit. Yeah, that's better. Oh, it won't let you because it sees the bottom edge as being out of bounds for some annoying reason. You see that? Curse you, Eagle, for not, you know, I've got a license for Eagle even, but it's just not this version. But it's like there's no difference between the versions. They just want you to keep buying new licenses. But of course they do. So I'm just going to waz these in. Of course, later I'm going to go in and finagle these. Or I won't. I'll just post it on GitHub and let someone else do that, if you're that bothered. We just do it really nasty. What have we got? 2, 4, 6, 8. Here we go. 10, 12. Look at that. We're really sciencing that up, aren't we? Yeah, Custado, you really don't get many dead STs, and that is a godsend, because clearly, unlike Amigas, which are croaking every 2 minutes, we're pretty lucky with it. And the power supplies in STs are really quite good too, so there's a lot of good going on. 12, 13, but yeah, they do from time to time, of course. 15, 17, 14, come on, come on. 18. Well, that's looking all right, isn't it? Look, there we go. We're really getting that in there. We're getting the density in there. So, yeah, I don't know if there's no parts to break. Depends how you view that. Plenty enough in there potentially to break, though. All right, phew, finally. Now we've got our last components up on the high level here. So we've got to work out if those are our LEDs on that side. We probably can do some routing to fit them. So what's that now? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, so we're going to go for... Just looking at something here. Just because we're putting it on the other side. 10, 11, 12. Oh, so you've actually got the DMA fault. I just don't know if they're, because I keep reading. Some people say it doesn't exist, and some people say it does exist. And I know Chrissy on the Discord, I think he just changed his DMA chip and everything's working. So I don't really know what goes on and how do you test a DMA. $15, $16, $17. Last one, 18. Nice. That's good. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So do you remember there's 15? We've got too many, haven't we? Look at that. I put 1 to 9. That's bonkers sauce. That would be a crazy layout. I like my OBS is telling me it's disconnecting and connecting. So I don't know what's going on. Right. 23, 24, 25. 25, 27, 29, 31, 33. There we go. 20, 22, 4. Ah, nearly there. 6, 8. This is a lot of messing around building this thing. However, I really doubt anyone's actually going to build it, but you never know. How have I got 2 extra resistors? Yeah, they aren't 2 extra, they just live here. Good. Only getting audio. And maybe, or maybe not, the stream will come back. Right, I just kicked that again. YouTube messing around. So, let's just start allocating some channels now. A1. Yes. Oh, do you have to say yes every time? A2, click, click. A3. A7. A8. A9. Is the stream offline? Maybe it is. Something odd happening here. Who knows? Do, 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 do. Do, 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 do. Do, 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 do. Oh, streaming might have come back on. I think it came back. Oh, we lost all of our views. Chrissy, we've lost like 24 people. Now it's just a more intimate crowd. Right. So D1, D2, D3. This will be D4. D5. D6. Oh, one more. We're done. Sort of. And we're going to paint the last one. Chrissy, where are you? Are you even on it? You weren't on here earlier, were you, Chrissy? You were waiting. You were waiting because you were hoping I'd be going on Craigslist and we'd do one of our little Craigslist things, but that's not happening yet. That's later. Anyway, this is the worst layout in the world, and it's not even logical right now. It's not even logical because I'll tell you what, you've got. If you look at the address lines, you've got 1, 2, 3, 4, 5, 6, 7, 8, 9 here, and you've only got 7 and a 6, so it's a lot messed up. It's all really messed up. But again, I'm just laying it out. I'm literally just going to lay it out however I can make it fit, and it's like, nah, that's all I'm doing. I'm not even going to tidy them up. If you want to make it, you can make it all wonk. Oh, I wonder if there's... I tell you what, is there a way? There used to be a way. Let's see here. I think it's part of the schematic tool. There was a way where you could group select. Let's see if we can group select. No. You could select all the objects and you could say all of them line up. Like you set the x-axes to be the same value. So I don't know if that's possible. What? No. This Ned. Just a little glitch. Yeah, it is working, you lion gits. It is working. Is that just you were just paying me back for making such a terrible PCB? Come on, select, you git. Why isn't... Anyway, there you go. It's just Chrissy lying. Stop lying, Chrissy. We should do a layout competition. These are like the parts, right? You're not allowed to change the parts, but who comes up with the best layout? Oh, who comes up with the best layout wins one of these. How about that? That's a good prize. That's worth real money, that is. It's not just a made-up prize. And another thing I was thinking about maybe I might not go to Blackpool this year. I'm kind of like not feeling it right now because I'm a bit busy. And then the thought of having to do a 5-hour drive from London to Blackpool is like kind of getting me down right now. So... Are these all the data lines then? Let's just see. So we've got 1, 2, 3. So some of these LEDs. Some of these LEDs are the data line LEDs. Whoever gets their design stolen. Exactly. Whoever does it gets to give me the design and I will put it on the shop. Right. So you see these LEDs where it says 14, 15? I kind of feel that maybe it might be worth just D1. renaming some of the LEDs so that we know what they're for. And because these are the data line ones, there's not so many, so I think it's easy. And I've already done it wrong. Okay. I already did it wrong. So this one would be D1. This will be D2. This will be D3. This will be D4. This will be D5. Holy smokes. And this will be D6. Oh no, I've just realised something. It's 16-bit. No, we can't do this. This is 16-bit, guys. Remember, these are like a high byte and a low byte you get out of this, right? This is 16-bit. So, you know what that means. That means we can't make this. This is just stupid now. At this point, surely, the insanity of this pod. No way. Okay. Oh. Okay. Now, we do have one saving grace. He says, with a little bit of a tear in his eye. The first thing is I'm going to wallop off these caps because you don't need them. Let's get rid of that. Let's get them out of the picture because they just confuse us, right? Okay. Now those footprints that we're using are good, but we still need two separate EEPROM footprints because that's giving us the two parts of the address line. But because there's no chips being fitted here, yeah, do you remember there's no chips being fitted, we can mount all of this in that same space. So, Mr. Miggins can potentially do something. Look at that, it looks like the Leaning Tower of Pisa. Get your Leaning Tower of Pisa going on. That fits. That fits. I reckon that fits pretty good. Make the board mega long. But Chrissy, I wanted to keep the board the same footprint to fit in your lovely case that you designed. Yeah. Nigel, or we could use one of these OLED screens that literally, what does it take up, these OLED screens? Oh, that's in Imperial. It takes up, if you put the whole PCB on, it's 4 centimeters by 12 millimeters. So that's 40 by 12. That would have fit better, wouldn't it? Oh, what do you think, Rob? Do we have to go to dust? I think I've been focusing too much on trying to put these down in a really neat way. I think you just paste it like that because surely Eagle knows what's best. There's been no time ever when a CAD software gets it worse than what a human could do. So I reckon that's good enough. We'll just wedge them down a bit. I'm just squidging them down so that they can fit on the PCB a bit better, and I think that works too. I'm going to do the Amiga version of this next as well, because I feel with all these Amigas dying, you probably need more diagnostic tools than the ST, to be fair. Look at that. There. And then we just got these. I don't think it's going to work out, guys. Okay, so that might save some time just to put it that way. Look at all the LEDs. All the LEDs are lining up perfectly. So Rob, what CAD would you do this in? You'd use it in some other crazy CAD. Oh no, we don't want that. Don't want. Rob, are we going to be playing some Rainbow Islands? Is there the arcade of Rainbow Islands? We're going to clock that while getting drunk? Is that the plan? That's looking pretty good. Yeah, it did auto-place the components. That's what it does. It just put them on randomly. I love the idea, though, that if someone actually made this exactly as it's laid out, with all of these random address lines, that you wouldn't even... You'd have to have a lookup table to try to just figure out what LEDs are flashing where. But maybe it doesn't matter. I'm thinking maybe it just doesn't matter, because this board is just designed to show you that the LEDs are working. You know, that none are like never coming on and none are like staying on permanently. So you could read off what the address is. And you literally could make this. If electrically this board hooks up, and it looks like it's going to use about 1 billion wires right now, because look at it. Look at it. But let's just for fun get to the auto router. And I'm going to turn the maximum running threads down, because last time we ran this on 8, it actually crashed the stream. And in fact, I'm thinking because we've got ground planes in, let's take off the ground planes first because we don't need those. I don't know if Gauntlet is finishable. I don't think it is. That's my gut feeling on Gauntlet. Right, now we can auto-route. There's a little gotcha there, by the way. If you run it at a certain point, then it will actually erase back to your previous version of your CAD, and that would screw you up. Don't do that. But Rob, that is how it is. The sockets are on the underside and the LEDs are top on this. So I know you missed the beginning. So this board goes in like this with the chips on the bottom, and this daughter board actually goes on top. That's how that works. Oh, you mean literally resistors and transistors on the other side, which is totally possible, Chrissy. Yeah, because it's already going to be... It's if that's your PCB, imagine this one is a daughter board that actually sits on top like that. So yeah, you've got loads of room, because if you use a socket, you've got way loads of room. Damn it. But then, you know, I'll leave that to you guys, because this is a competition at the end of the day. And whoever comes up with the best gets some meat. Gets Dr. A's sous vide meats. I'm going to hand deliver them to Blackpool on a silver platter. Look at it churning away. It's still thinking about it. It's giving it a damn good go. I reckon it's going to do it, you know. I think it's so close. Look, it's 98.5%. It's still thinking about it. And maybe you just leave those last few percent undone. Let the end user figure out where to put their jumper layers. Yeah, let's go 16 layer. Does routing kill the screen? It's... Oh, you know why? Look how many jobs it's running. Do you remember? 3 FPS. Routing is eating all the CPUs. Is it done? I think it's done. 98.5%. That's the best it can do. Let's see. End the job. Wow, look at that. So that would... I don't think it would work, because I think you've got a short here between this transistor and that footprint. So yeah, you're not going to pass the DRC. But I think you could technically finish this. I think you could probably work out how to get those last few. I'm almost tempted. I think we need to complete this. I think we need to make it actually properly DRCable, because we're so close. It really is close. So let's just shift these transistors across. Hopefully my FPS will recover. If we do that, look, those all fit really nicely there. Oh yeah, but exactly like Chrissy said, you could just flip a whole set of components onto the back and arrange all of the LEDs exactly how you want, but that's too logical at this point. I think we're just going to finish this off We're there. We're there. We're nearly there. It's makeable. It is definitely makeable. You could make it. Now, I don't know what's been going on with the PCBs I've been making. I've got a Cortex set, if anybody wants to make a Cortex, an ARM Cortex board up. T23 and T24, where are they? T23, actually, while I'm here, I'm just going to space these out. Where's T23 and T24, Chrissy? Help me, man. Help me, man. T23. There's a way of finding parts, actually. Is it Control F? Nah. T23. There's 21. 22. Where am I looking, Chrissy? Come on, come on. The fact you've mentioned them suggests to me that they're really crazy. On the ROM 3 low. Oh, good spot there. Whoa, that would have been bad. That would have been mega bad. I like this LED 8 placement as well, just randomly. Although, to be fair, where are all the other LEDs? Oh, they're actually here. See, we could actually do that. Look. Oh, my word. 8, 9, 10, 11, 12, 13, 14, 15. 7, 6, 5, 4. There is actually a method to the madness. Holy smokes, there is method to the madness. Right. I'm almost feeling... Oh, some of these are really messed up where they're going. Yeah, best not worry about those too much. Let's just make sure we auto route it and we're done. I think we're done. What I'm going to do though is I'm going to save that again. And when I hit the auto router, how many threads? I think we've got to do it maximum number of threads to be like 2 now this time. Let's see how it kills the FPS. Do it. Start. So what I'm wondering is, if we want to, we could design this with a really organic layout. We really could just put the LEDs wherever we want. But I think realistically, shorting in the right socket. Are we? I think I fixed that, didn't I, guys? I think realistically, if you were going to make this and you were going to make it a product that you were going to have to manufacture, you'd be using those arrays. I think resistor arrays and transistor arrays are going to be your bag. But because you'd still need a lot of those, I think you probably would want to start doing something programmable with a programmable logic or some other stuff. And if you're going to get the buffering in, so you can use one of those or a microcontroller to start handling stuff for you, then that's giving you a lot of potential I/O for future projects. So, you know, FPS is still good. So we know then if we're running it on two threads, that's okay. And we have 100%. We've got it. We're already at 100%. It's trying to optimize the vias now. Oh my gosh! Look at Route 5. It had 400 vias in it. Lucky you're not charged by the via. I'll have to speak to JLPCB or Seed or whoever it is who wants to give me free PCBs at the moment and just give them a board with 400 vias on it. I don't think I would want to spend the time making this board, because imagine how nightmarish it is to just get those resistors in. Because you've got 2 different values of resistors, so you can't just go and chuck resistors in on this. This is the kit to somebody for Christmas who's bored and has got a brand new soldering iron and just wants to go nuts. Wow, look, Route 9. Route 9 is 100% with 153 vias. We're winning. Look, we have actually a more optimal design. It's coming in. It's doing a good job here. Come on. Come on now. Can we get a better? Yeah, burn out their drill bits. Although... I did send a picture on the Discord. I have actually set up my milling setup. So technically I could mill out this PCB and have a go at it. Oh, look at that. Score of Ensis. Dr. A. A Judge Dr. A badge. That is cool. That is literally the coolest thing I've ever seen. I'm going to need a wee little gold chain to hang off that. That'll be a good old thing, wouldn't it? Is it finished? It's finished now. Back to work. Right, so we've got a route with a... Look at that, that's so neat as well. 153. Why is it saying this one is better than this one for some reason? It thinks that one is better than that one. And it's down to the cost of copper or something. For some mathematical reason, it'll be thinking that's better than that. But I think that's a good job. So we're done. So all that remains is that we go on the old GitHub. And I find my login account. Here we go. So we can shut down Eagle. Done a bloody good job there tonight, haven't we, guys? We're going to do a new project somehow. How do we do that? Here, new repository. Oh, is it? No, is it? Yeah, it is a new repo. Atari Diag ROM. What is it? LED board. That sounds pretty good. And we'll initialize it with a README. We'll make it public. We do create suppository. And then I go into my... Which monitor? Which monitor is it going to come up on? That thing. And then I'm just going to put in my BRD and my SCH upload files. Boom. And I'll make the commit. No one is ever going to build this. However, the best design competition to end when I decide. So it could go on forever and you never win. The best design competition will never win. Will win a Diag Cart PCB. You get the PCB. That's all you want. You don't need the ROM chips or everything. But you can badger me and I'll give you one. I don't care. Oh, it's going to be like a disco card, isn't it? Rob, are you going to build it as is, though? Yeah. A giant gold chain. I really want to have a... I've got motorbike leathers. I'm so close to having a Judge Dredd cosplay now, aren't I? I'm so close to having it. It's tempting, I have to say. It is really tempting. I'm going to post it into the lobby of my Discord as well, that link. So yeah, I don't know. I wouldn't recommend building that as is. I feel that we should put a picture in the repository as well for people, because the last thing you want is somebody pulling that and actually trying to make it without looking at what the board layout is. So I'm going to try with the new Microsoft snipping tool called Snip and Sketch. It looks like that. And we do save. How do we save it? Save as pictures, downloads, Atari LED. Oh, look, there's me thumbnails from earlier. I'm going to see how we upload again. We can just do upload again. That's all we want. And then I'm going to go to my downloads. I don't know if you like me. I put everything in my downloads folder. And then every now and then I just delete my entire downloads folder because everything is on the cloud. RGB, baby. Yeah, you'll go with my recommendation of not building it. No, I think it will work. I didn't check the DRC, right? But I can't see any real reason that it shouldn't work. It's just make sure when you make it, if you get it made, just get the wires tented, because some of the wires are pretty close and they might short if you try to, it's a bit fiddly and you might just short them out. Everything in the desktop. But look at my desktop, guys. Isn't it beautiful and clean? it's beautiful and clean because I've got an app that does that. It hides it, and it hides it across all 3 desktops. And not only does it hide it, it saves the positions of your icons so that if you plug in a monitor or you hit the desk and one of your monitor falls out, that all your icons shuffle and jump onto one screen. You can load back the positions. I'm going to show it to you because I actually quite like it. It's called Desktop OK, and you see it here, Desktop OK, and you see there's a timer here at the bottom called the Icons timer, and you can set that to how long you want your icons to be visible. And it's got loads of weird features. I quite like it. I don't know if it's stealing my information and sending it to Russia or something, but it's pretty cool. So you've got auto arrange stuff, auto save. So it's saying every hour it's saving all of my icons anyway, and that's where you get these standard layouts, and you can just change them. So I think that's kind of cute. So I just run that minimized, and it keeps your desktop clean. So Costado says, this is one for Big Clive. I'm sure he won't mind hand drilling the wires. He does love the LEDs. If there's anything old Clive loves, it's the old LEDs. So he probably would be quite keen on that. So I don't know. I feel that I must have been streaming now for a couple hours. But I don't feel like running away just yet. It's probably a good time to talk about the channel briefly, just briefly, because I've got a little bit of video footage today that I did of the Oculus Rift S that's over there. So you could see an unboxing and some of the features of that. But I mentioned in that video that as of late I haven't posted too many videos right now, and it's not that I haven't had things to post about. I get stuff through my door all the time, and it's not really that I don't have too much time to post, even though I have been away for the last 2 weeks. It's just I'm kind of not having the mojo to like just do the same old sort of vlogging stuff. Do you know what I mean? It's like, here's like for example, here's that Ledger thing, you know, this Bitcoin blockchain device, right? And I've had a play with that. It's pretty cool, but I don't feel massively compelled to just do a video about it, especially if people aren't interested in it. And I'm kind of going off the whole like YouTube thing at the minute, because YouTube's really treating my channel in a weird way. So my subscribers are really, it's like a third or a quarter of what it used to be. However, the views have gone down a bit, but not a massive amount, and revenue on the channel has actually gone up. So the channel revenue is great from that perspective. You know, I could buy a one of these a week or something. I say a week, a month, a week. And by the way, this is that power bank camera thing, which was kind of cool, but that got sent to me anyway. Yeah, so I don't know. I don't know what YouTube wants, and I don't know what you guys want. I don't know if it's worth persevering right now at this point, or if I should try to find some other videos to make that might inspire me. When I started out, I used to really enjoy all the effects and, you know, the whole process of making videos, and I have bought all the equipment to do it, but I just never really used it. I've just been doing the hands. Got like 1,200 videos of me doing the hands. So I don't know. As I said in the as I say in the video that you're about to see anyway, just give me a comment in the chat or Discord or something. Let me know what type of videos you want to see, because I kind of thinking I'm not going to play YouTube at their game anymore. I'll just make what you guys want, and we'll see how it goes with that. You know, views, subs, whatever. Let's just see if it's a natural thing. If we get them, great. If we don't, it doesn't matter. We've got our Discord and we've got our Blackpools of this world. Anyway, I'm going to go away now, because I'm sure you want to go and get to bed, probably. Oh. There's a lot of one more thing. I watched Goliath on Netflix. Goliath starring what's his name? It's like Billy Thornton, Billy Bob Thornton, and it's really good. I binged the whole series 1 of Goliath. I hear series 2's not so great, but then series 3 really starts ramping it up again. So if you're interested in kind of semi-procedural lawyer drama, then Goliath is the one for you. If you're interested in more violence, try Ozark. Ozark is brilliant. So there you go. I've moved in seamlessly, segued into the world of Netflix TV show reviews. As ever, thanks for watching. Bye-bye.